Welcome to the podcast, BIM GIS Today and Tomorrow, where we will discuss a variety of topics including new technology for building information modeling and geospatial information systems, specifically for the infrastructure industry. Your host today is Stephen Brockwell, president of Brockwell IT Consulting. Stephen brings with him an extensive experience in the infrastructure and geospatial industries through his participation in projects for some of the largest utilities in North America. Stephen founded Brockwell IT Consulting to provide independent and impartial business and technical leadership for the geospatial and infrastructure communities. Stephen has provided leadership and guidance at Autodesk, SHL Vision Solutions, and GeoVision, and has been a regular presenter at Autodesk University.
Hello, everybody. Welcome to Brockwell IT's first podcast. I'm here with Orest Halustchak, who is a bit of a legend in our community. He's been in the geospatial and infrastructure IT and software development since when, Orest? 78, 75?
About 78 or 79.
Yeah.
That time, dating myself.
Right. And at one point, anyway, just after an initial startup inside a company called System House, Orest was with a company called GeoVision,
Right.
which developed one of the first, if not the first, all relational database implementations for geospatial analysis and modeling and the full suite of products. And so Orest has been, for me anyway, a real mentor over the years, helping me to learn how to think about problems, how to approach the organization of information, and how to both communicate it to customers and to communicate it with technical people, developers, and that kind of thing, who have to build the software that people use. So one of the things that I think Orest, who, when he was with Autodesk, by the way, I didn't mention that, but Orest was with Autodesk for many years, more than me. I was with Autodesk for almost 10 years. Orest, how long were you with Autodesk?
It wasn't quite 20, but it was
Mm-hmm.
It was a while, and I was involved as a software architect working on components of Maps 3D and InfraWorks primarily.
Right. So over that time, there's been a big convergence, I would say, certainly from a business process point of view. But you mentioned InfraWorks as a product. I think that's really a good example of how there's a big convergence of building information and infrastructure information, both necessary to complete a project. You can't build a building without having water, wastewater, electric, gas, all of the physical infrastructure supplying it. And you can't really plan for your physical infrastructure as a city or a federal agency or even a private enterprise if you don't have the knowledge of where the buildings are going to go, who's in the building, what the load is going to be on the system, and so on. So this convergence of building information and infrastructure information is driving a number of initiatives in the industry, one of which is a thing called Building Smart International, and there's a Canadian group that we're members of for Building Smart Canada, that their mission really is to put in place standards that help the exchange of information for the building and the infrastructure across the whole life cycle, from conception through to design and implementation and construction, and then beyond that into the operational use of the building over time. And just from a point of view of introduction about Building Smart, one of the key things is that it is an open standard, that multi-vendor, it's neutral, it doesn't advocate for one vendor or another. There's a certification process for that. It's broken down into three primary elements. One is the process, and there are some great process guides about how to change your business practices to be kind of compliant with Building Smart. There's a dictionary which defines in really rigorous terms what everything means. And this is an international standard. So it means that it's a standard that everyone across the planet agrees to as far as the, meaning of, ducts and, concrete, and all of those terms are unified so that everyone understands what we're talking about. And then from there is the data. And the data is, part of a model that allows the exchange of the information and standard processing. So that's a very high level overview of the sort of basic standards of the Building Smart concept. And what I wanted to do today was to talk with Orest about, his thoughts on it from his experience in the industry. He's been on some of the committees. He's been, participant in OGC, the Open Geospatial Committee, for many years as well in the past, and just why it's important, and what's the history? How did we get here? And then, particularly with respect to the GIS and the building side, Revit, ArcGIS, these kinds of things, InfraWorks, Civil 3D. How is Building Smart helping these products start to, kind of be able to more freely exchange data in meaningful ways? So that's essentially the topics of this conversation. And with that, Orest, let's hand it over to you. What's your perspective on the history of how we got to where we are today?
Okay, thanks, Stephen. Maybe I'll step back a little bit. Standardization has been part of our industries for a very long time, and I think everybody understands the benefits of standard processes, standard ways to access data, standard terminology in allowing customers to use a large set of tools and still be able to interoperate with their data and their processes. My history goes back more so with on the GS side. In the early days was the OGC, the Open Geospatial Consortium, when they started to develop standards for exchange of geospatial information, focused on the GIS aspects of the industry. They started, I don't remember exactly, sometime in the mid-90s, but focused on GIS, spatial data. IFC, as a standards organization, or Building Smart International as a standards organization, IFC, Industry Foundation Classes, is the standards. Their history started with building architecture, including the various architectural aspects of buildings, mechanical, electrical, plumbing, fairly detailed information on what is needed to design, build buildings. But the interesting thing recently is these organizations are communicating with each other a lot more than they have in the past. When you're designing a building or you're designing a site, these things aren't done in isolation. And with a lot more interoperability between tools, availability of tools to work on these things, it becomes more important to be able to work with these together. You may have engineers, architects designing a building, and you may have other designers working on landscape and other designers working on road infrastructure. And they all use their own tools, their own technology. But at some point, we want to bring those together. And how does the building interact with the site? How does the road network affect where we want to position the building, how we want to design the building, how we access the building? So all these things need to come together. We don't necessarily need to have exact same tools working on all these things, but we need to be able to work with all this data together to a certain extent. Mm-hmm. And the exciting thing with what's happening with Building Smart and OGC is the collaboration on designing infrastructure standards that apply in both sorts of application areas. Right. So this started with standardization of alignments and working on road infrastructure and rail and bridge infrastructure. And with a collaboration between standards organizations, these standards are the same. So whether you're working on the building architecture side of things and you want to look at the site information, or if you're working on your landscaper and working on the GS side of things, you're dealing with the same model under the covers. It's the same data that you're sharing, so you don't have any loss of accuracy. Work that happens within one domain is immediately available for people working in the other domain. It just makes the whole workflow more accurate and more efficient.
It's interesting, you know, when you talk about the OGC side of things, I remember from the very early days, you know, we were focused on the simplest of possible standards of geometry interchange, if you recall. You know, I mean, that was how far we, you know, we had gotten really, and that was tough enough to get sort of standard representations of just how do you really represent geometry. And, you know, vendors used to sort of see that in some ways as very proprietary stuff. Now with buildings, and in physical infrastructure that feeds them, you know, you're looking at models that are just in scope so much larger, you know, and I wonder, you know, like how was it that, you know, there was sort of this sort of very simple kind of way of approaching things. In some sense, it's gotten much more complex. Do you think the complexity is something that customers need to be concerned about, or is this even maybe an advantage from a complexity point of view?
That's a good question, and I tend to see this as an advantage. The complexity, it's important to deal with the complexity, and I think some of the participants that work on these standards organizations, a lot of their problem is trying to figure out how to manage the complexity of the data that they're working with and how to describe it in a logical sequence from the most detailed to the most general views of the data, whether you're dealing with the very fine point by point representations of things to what's the floor of a building as a larger component, and how do you hide the complexity of that. And I think the standards help do that in a certain way by defining a logical hierarchical representation of these things that everybody agrees to,
right,
and participates in.
Yeah.
And yeah, I do remember the early days. You mentioned, Stephen, the early days of OGC and the first spec, the simple feature spec. And I remember we were discussing, well, how do you represent a point? How do you represent a polyline?
Yep.
This is 2D or 3D. How do we talk about that? What is the terminology? Then, well, what format do we put that in so that product A can send a polyline to product B and get the same polyline and show that exact same polyline in their applications? And that was pretty exciting. But yeah, these days we've gone much further and building on all those levels of complexity into these days something that's very complex when you talk about a whole building and everything that goes into it, and not just one discipline, but there's many disciplines involved in that building design.
Right.
You know, the structural and the mechanical and electrical parts.
I think that's a really key component of it, right? I mean, some vendors, they really do try incredibly hard to standardize on a single product for certain things, but you know, there's always a limitation to the specialization that a particular software product might have. If it were from, you know, an Autodesk Civil 3D, it has its strengths from a road design point of view, for example. If you're Bentley, that's another sort of, you know, inroads, very different approach, but also has strengths. And the thing is, you know, under different circumstances, even for a single project, both products could end up being used conceivably, because the city or the owner may design one thing, construction may use civil. So you could have both products easily in a large engineering design project for infrastructure, and certainly for buildings too. And then on the other end, you've got the GIS part of it, the visualizations, and if you look at what Esri's doing to make that shareable, to make kind of intelligence around it shareable with scenes, and like, it's a very different world of complex information that is being represented in meaningful ways to the various constituents, right?
Right,
But,
and it comes down to the data as well. Even if you are using one product for your work, the ability to share data and find data and use it without a lot of complexity really helps move your projects along more quickly. If I can get parcel data from a city website, or I can get terrain information from USGS, or I can get other information that is just there and is important for my project, because there's standardization in the representation of this data, I can use it. I can just use it immediately in my project, and that's incredible benefit.
We did a large study for one of the state transportation agencies in the U.S. A number of years ago, and it was kind of an enterprise architecture strategy document we were working on that tried to, and that was in relatively early days of sort of JS, CAD, real CAD, Civil 3D integration. And one of the things we found was related to that, because a huge part of the engineering job was document retrieval, right? So, where is it? What is it today? What are the encumbrances, the rights of way? All of the various different levels of information took weeks to tabulate and collect before you could even start designing. So that kind of interoperability of data is an incredible advantage if customers have it in place. Right?
Yes. And then being able to get updates if you have a long-running project and the data changes, you can have to find the updates and incorporate them. And again, using standard data formats, it's a lot more doable than if you had to redigitize data or...
Now, speaking of that part of it, so in terms of IFC, the industry foundation classes, as they're called, which is sort of the data side of that little, there's in the sort of building smart kind of foundational concepts, there's a triangle of the, dictionary, meanings, concepts, processes, and then data, which is where the IFC part comes in.
Yep.
So how far along, just like give us an overview of how far along they are, particularly on the infrastructure side, and what's promising about that on the specifics.
Well, at this point in time, there's been a committee, we call it an info room, I think, working on the one aspect of infrastructure, and that's something called an alignment. Alignment is a foundation for a lot of other infrastructure like roads or rail and other infrastructure components, pipelines. And the organization has been working on that for a number of years now, and there's actually one or two versions of the IFC specification that include the definition of the alignment data type, both horizontal and vertical aspects of it. And recently work is happening on, I think road is the next specification that they're working on. And I remember seeing a call for participation about the middle of last year to work on the road model specification. And recently, there has been another call for participation to work on site landscape data modeling, not part of the infrastructure standard. And somewhere in between, there's work happening on rail and bridges and tunnels. And so at some point, those over time will be added to the standard.
I mean, it's interesting because people sometimes forget how much money actually gets spent on infrastructure. I mean, worldwide, we're not really keeping up. In North America, for the most part, we're not keeping up. But it's tens of billions of many tens of billions of dollars a year is spent annually. Just on the federal side in the U.S. on infrastructure projects around the country, and the kind of capital involved, the need for investment, and the need for efficiencies. I mean, there are plenty of inefficiencies in the process, and on a political level, you could argue about the value of them, but there's built by American. There's labor, and union constraints. There's environmental reviews. There's transportation alternatives. Is this a transportation kind of concept even that is going to be beneficial to changing the way people do move around? So that's another advantage that I see to building smart, at least in its infrastructure kind of concept, is at least we have one place where you'll be able to start to smooth the process. You have so many other obstructions to getting projects done cost effectively, that if you have this ability to share information without massive translation, but the semantics of it are the same, I think that makes a huge difference.
Yes, I agree. And there's one other aspect I just thought of in terms of data sharing that the standards help, and that's for these projects, infrastructure projects, there's always an approval process, that there's an organization, whether it's a government organization or other organization, that reviews design of a building, reviews design of a new road interchange, and has to provide approval for the engineering aspects of those projects. And if you can share your design with these organizations in a digital form, that makes it a lot more efficient to get through those processes, a lot more accurate than if you're having to generate paper plots, for example, like in the old days, and have that reviewed. It's a lot easier to share that information and make updates more quickly and get to an approved design more quickly.
It's interesting you say that too, because there are some cities in Canada in particular, some in the US too, but in Canada I know of a few that are starting to provide digital portals for getting data to support projects and to put in designs for approval and so on. But a lot of them, you're putting up a PDF or some other kind of reduced thing, or there's limiting standards to kind of make a level playing field, and those standards for those cases are dumbed down to the point where it's a visual representation, and you really have to infer design intent, because you can't actually decode the design intent from the data, because the data has been flattened into, even if it's a 3D model, it's a visual model of the design intent. It's not the design itself, and that means, you're kind of, as someone who is making an assessment of the viability of the project or compliance with legislation, they have, less to go on. If you have rich, building information or infrastructure data that is correct and, again, like has this sort of consistent semantic model. So an underground pipe really is an underground pipe. The fittings and appurtenances are real. Then you actually can make decisions about whether the design is going to work or comply with bylaws.
Yes.
Maybe just before the closing thought will be around, some of the work we've done with Autodesk on the integration side, because I do want to talk about that a little bit. But maybe you can give an overview of where some of the vendors are at with Building Smart and IFC compliance, specifically the vendors, that we are most familiar with, the Autodesk and Esri's of the world.
Well, I think by and large, vendors are very proactive in participating in these organizations. So if we talk about Esri or Autodesk, they're very active in these organizations. I think all the vendors see the benefit of supporting the standard, because then that gives them a value that the customers will have. So Bentley, NES, RI, and Autodesk, and Intergraph, and other organizations, they support these standards to a very high degree. So I'm not sure if that answers your question, but
no, it does. I mean, it's just not everybody may be fully aware of that, and the degree to which Building Smart is really there's a landing page for it on the Autodesk website for Revit, for example. And Revit is an interesting one too, because even Autodesk, if you look at their workflows, they've really worked hard. It's not perfect yet, but multiple Autodesk products participate in the full life cycle of a building design, even a building design. And Revit also at the same time gets used for the final construction modeling of some infrastructure things like, concrete pylons and all of the physical elements of a bridge. Revit is used quite frequently in those final phases of a project. So it's interesting how the support for IFC has actually been quite strong on part of both Autodesk and Esri. And, I think it's to the benefit of pretty much everyone. And it's a progression. It's not like it's going to stop there. It's getting better and better as time moves on.
Yeah, and I think users drive a lot of that. I think users these days are very well aware of the tools that they're using and their requirements for sharing data. So the users will ask the vendors, how do I get my data from here to here? How do I share my data between this one? Or I understand there's a new standard being developed that will help me share my infrastructure data with my architects. When will I be able to use your product to do that? And that happens, and that drives the industry from that direction.
Mm-hmm. I mean, I'll mention it just for the sake of completeness, because if anyone's listening, they can look it up here. I mean, just a Google search on, Autodesk IFC Revit manual. There is actually a really nice 50 some odd page manual on how to, kind of comply with IFC using Revit, and how to prepare your data for IFC export and those kinds of things. So it's something that they're taking seriously. And, for a number of releases now, you've been able to use it in Revit to export IFC models that you can then share right across the process, including to some extent on the Esri side as well. So where to now? What are the next things that we'll be seeing that you're aware of on the Building Smart IFC front that will take this further?
Well, I think the current areas that are being worked on with road and rail, I think, are extremely important parts of the design. The earlier work on alignment is there to support these new types. So I'm looking forward to advancements in those standards, and I think there'll be a big boost in being able to share infrastructure data between these types of projects.
So I think that's a really good closing thought. And thanks so much for your time and expertise, Orest. It's a great pleasure of ours to have you on our team. And I just want to thank everyone out there who might be listening, and encourage you to give us feedback at Brockwell IT on our website, and let us know what you think about these podcasts, and if they're useful, and the kind of other information that you might find meaningful to your business. And thanks again.
Thank you for joining BIM and GIS Today and Tomorrow. If you enjoyed today's topic or would like to hear from us about other topics, you can reach us at www.brockwellit.com, on Twitter @BrockwellIT, and on Facebook or LinkedIn.